Assalamualaikum and hi everyone. So in this video we're going to focus on what are the formulas that you can use to estimate population mean. Okay, so we're going to learn on 3 different formulas of confidence interval to estimate population mean. So I hope you guys still remember what is confidence interval. Do you still remember? Confidence interval is the interval estimate that we use to estimate parameter. And specifically in this video, we're going to focus on the parameter of population mean, right? Before you can do that, before we can actually use the formula to estimate population mean, you need to make sure that the data, okay, you need to make sure that the variable follows a normal distribution. Okay, that the sampling distribution of the mean of the sample mean, okay, which means just meaning that your variable has a normal distribution. So throughout this course, okay, all the data given in all the questions will be assumed to be normally distributed. So this assumption, okay, we're going to assume that all the data provided to you are normally distributed. So because of that assumption, therefore you can conduct analysis using confidence interval in answering any of the confidence interval questions. Okay, so please remember, this is a very important assumption, because if your variable is not normally distributed, okay, in practical, if your variable is not normally distributed, then you cannot use confidence interval to estimate your parameter. Right now, so based on the central limit theorem, the confidence interval for the population mean mu can be constructed as follows. Okay, P, all right. So this is probability. Okay, so the probability of getting the interval is equals to 1 minus alpha. So this is the interval. Okay, so do you still remember that a confidence interval consists of lower boundary and upper boundary? Okay, so basically the lower boundary and upper boundary formula is for confidence interval for population mean. Okay, so we are now focusing on confidence interval for population mean. So the lower boundary for the confidence interval for population mean is given by sample mean minus estimation error. I hope you guys still remember. This is estimation error. And the upper boundary is given by sample mean plus estimation error. So generally, this is the formula that you can use to estimate population mean. So what is 1 minus alpha here? Okay, so this is the confidence level. So do you still remember from the last video? 90% ke, 95% ke? So yeah, the question will give you the confidence level, don't worry, okay? And then from this confidence level, you can actually obtain alpha, which is alpha is the significance level. Okay, alpha is the significance level. Now, the confidence interval for population mean can also be written as this. Okay, it's just an interval, all right, with the lower boundary and also the upper boundary. Or it can also be written as this. Okay, lower boundary is smaller than the parameter, smaller than the upper boundary. So these are 3 different ways that you can write down your confidence interval. Now the important thing is that you now understand that the general form, okay, the general formula for the lower boundary is x minus e, and the general formula for the upper boundary is x bar plus e. Okay, yeah, so this is the B and also A. Now these are the formulas. There are 3 different formulas that you can use to estimate population mean that depends on certain situation. Now, when you read the question, you need to identify whether or not population variance is known in the question. If population variance is known, so this is the formula that you're going to use. Okay, let's look at the formula, right? So this one, okay, is your lower boundary. So sample mean minus z alpha over 2 multiply sigma divided by square root n. So in this formula here, z alpha divided by 2 is called the critical value. So this is called the critical value, which you can obtain this value from your formula book, okay, from the statistical table and formula book. This book. Alright, so page 36. Alright, so this is the formula for the lower boundary, and for upper boundary it is sample mean plus Z alpha over 2. So sample mean plus critical value multiply with sigma divided by square root n. So this is the formula. Alright, next, if sigma square is unknown in the question, if sigma square is unknown, then you have two possible formula. So you need to check. If it is the case of sigma square unknown, sample size greater than 30, then this is the formula. So it's actually almost similar to the previous, to the first formula. The only difference is that the first formula here use sigma, and the second formula here use S. So here is population standard deviation, and here it's sample standard deviation. Okay, next, if the question, so again, the critical value you can get from page 36. And next, if the question given to you is the case of sigma square unknown and sample size less than 30, so this is the formula that you should use, okay? So let's take a look at the formula for the lower boundary. Sample mean minus T alpha over 2 nu, so this is the critical value, T alpha over 2 nu multiplied with the sample standard deviation divided by the sample size. And similarly for the upper boundary, it is sample mean plus, okay? Sample mean plus critical value multiplied with the sample standard deviation and divided by the sample mean. Don't worry, we're going to try a few examples that will use some of this formula. Okay, so now let's go to the first example. Example 2.1. A factory produces steel sheets whose weights are known to be normally distributed. Okay, so this is a standard statement that you will see in almost all of the question, right? With a standard deviation of 2.4 kilogram. A random sample of 26 sheets had a mean weight of 3.14 kilogram. Find a 99% confidence interval for the population mean weight and give an interpretation of the parameter estimate. Okay, now class, before you even attempt to answer the question, now the instruction in this question is that for you to find the 99% confidence interval to estimate the population mean weight. Okay, mean of the weight. What weight apa ni? Weight of the steel sheets. Okay, before you even attempt to answer this question, first you must be able to understand what is the population under study, what is the sample here, and what is the variable. Come on, give it a try. Can you please identify what is the variable in this question? Yeah, weight. Okay, this is the variable, weights of steel sheets. Yes. What about the sample? Yes, a random sample of 26 sheets. So the sample here is 26 sheets. So then what is the population? Perhaps the population is all steel sheets produced in the factory. Okay, now, if you're able to understand these three elements, then inshallah, you will have no problem in answering the question. Now that you know that 26 sheets is the sample and that all sheets is the population, so can you please tell me, alright, this 3.14 kilogram, alright, so this is mean. Is this sample mean or is this population mean? Look at the sentence. This sentence is talking about the sample. Therefore, this value belongs to the sample, right? So this is sample mean, alright? So now, after you are able to understand these three elements, next you need to write down the correct notation for each given value, alright? So for 3.14 kilogram, it's X bar, right? Sample mean. Next, 2.4 kilogram. It is a standard deviation, but is it population standard deviation or is it sample standard deviation? Look at the sentence. Is the sentence talking about the general population Or is the sentence talking about a specific sample? This is general population, right? Alright, so this sentence is for the general population, therefore this is a population standard deviation, okay? So you're gonna use sigma as the notation. Get it? Alright, so when you extract information from the question, now you know that, okay, you have a sample size of 26, sample mean of 3.14 kilogram, and population standard deviation of 2.4 kilogram. So the question given to you is the case of sigma square known. It is known. You know the value of the population standard deviation. Therefore, you can also know the value of the population variance. Am I right? So if sigma is given, if value of sigma is given in the question, so this is the case of sigma square known. So why is it important to identify what case is this? Because you need to choose one of the formula from the three formulas presented to you just now. Alright? Okay, so this is the case of sigma square is known. So therefore, you will choose which formula? The first formula. Am I right? You will choose the first formula in which you need to substitute all the value given to you. So you know this is going to be 26. Okay, sigma here is going to be 2.4. X bar here is going to be 3.14 kilogram, but you still don't have one information, which is the critical value. So you need to find this critical value from the formula book, page 36. So what is this critical value? It is Z alpha over 2. So before you can even find it from the formula book, you first need to calculate alpha. Okay, let's find out what is alpha value. So the instruction is for you to find a 99% confidence interval. So 99% here, class, what is this? This is yes, it's the confidence level, okay, which is also equivalent to 0.99. So 0.99 is actually equals to 1 minus alpha. So alpha is what we're trying to find here, okay, right? So if you know that 0.99 is equivalent to 1 minus alpha, okay, so therefore alpha is 1 minus 0.99. Betul tak? This is linear equation, okay? You just do some arrangement and you can get alpha. So it will give you alpha 0.01, okay? But in this formula, to find the critical value, you need to know what is alpha over 2. Okay, so this formula is alpha over 2. So now you need to divide it by 2 and you'll get 0.005. So this is the value that you need to find in the formula book in the stats table, page 36. Okay, so this is a screenshot. Okay, I took a photo of that page. Alright, so a small proportion of it. So dekat sini, okay, at this column here, you need to find the value 0.005. That will be your critical value. Okay, so where is it? It's here. Okay, so 2.5758 is the critical value that you need to substitute into this formula. Alright, so Z alpha over 2, which is also equivalent to Z 0.005, is 2.5758. There you go. So once you have all the information needed, once you have all the values needed to use this formula, then you can start your calculation. Alright, so a 99% confidence interval for population mean mu is given by 3.14 minus 2.5758 multiplied by 2.4 divided by square root 26. Alright, so this is the formula to find the lower boundary, which will give you 1.9276, and as for the upper boundary, it's actually the same thing. It's just that here it is minus and here it is plus. So 3.14 plus 2.5758 multiplied 2.4 divided by square root 26, and this will give you the value 4.3524 kilogram. So this is the confidence interval that you can use to estimate the population mean of the weights of steel sheet in this question. So we can say that the probability of the mean of the population mean to be within 1.9276 and 4.3524 kilogram is 99%. So how do you interpret this result? Okay, you're just gonna have to tell that, okay, what does this interval means? It means that we are confident, correct or not? We are 99% confident that the population mean is within these two values. Is that okay? It's pretty simple, right? Yeah, so this is how to use interval estimate, okay? Using confidence interval to estimate population mean, and this example is for the case of sigma square is known. Right, I'm going to talk more about this, okay? We're going to talk about the estimation error. Okay, so since you're doing estimation, what is the magnitude of the error made? Of course, when you're doing estimation, it does not give you the exact value of your mu because we are trying to estimate. So we are bound to make some error in our estimation. So what is the magnitude of that error? So we're going to talk about that in our next video. So basically, there are three different formulas that you can use to estimate population mean. So that really depends on the cases. Okay, if sigma square is known, it's this formula. If sigma square is unknown, it's this formula. Sigma square is unknown. Okay, meaning that the question didn't give you any value for sigma or sigma square. And then the sample size is more than 30. So this is the formula. But if the sample size is less than 30, so you need to use this formula. Thank you for listening. I'll see you in my next video. Okay? Bye.